Here we're going to look at question 28 on the ENGAA 2018 paper. Okay, so the first thing this question does is give us a lot of information. Now I've summarised it here for you. The first thing it tells us is that there are three detectors, X, Y and Z. The question then tells us that an earthquake occurs close to the surface of the Earth. We're told the earthquake travels at 4 kilometers per second, and then the X and Y detect the earthquake at the same time. Finally, we're told that Z detects the earthquake 1 minute after X and Y have detected them. Next, the question gives us three different statements and asks us whether they're true or false. So the first of these is that the origin of the earthquake is at the midpoint of the line XY. The second is that Z is equidistant from X and Y. Equidistant meaning the same distance from both X and Y. And Z is no more than 240 kilometers from X and Y. If you'd like to have a go at this question before we run through it, please pause the video just now. Otherwise, let's get on. So the best thing to do is probably to work through the statements one by one and work out if they sound like they could be true or whether they'd be false. So let's look at statement 1 first of all. So first of all, let's draw a diagram of X and Y, and let's imagine our earthquake occurring at the midpoint of the between the 2 points. Now doing this would satisfy our first condition, that X and Y would detect the event at the same time. But there's also some other positions of our earthquake occurring which could satisfy the condition. For example, if we moved the earthquake to occur on the bisector between X and Y, such as up here. Now at this point, it's still equidistant from both X and Y, so the detectors both detect the earthquake at the same time, but it's not at the midpoint of the two. Therefore, our first condition is going to be false. Let's now look at statement 2, and let's keep our earthquake occurring on the bisector rather than the midpoint of the two. Now, we do this just because it's a bit more general, I suppose. We know that the earthquake is going to appear on the bisector, but we can't be sure it's going to appear on the midpoint. So if we consider the earthquake appearing on the bisector instead, then it should give us a more sort of complete view of the other two statements. So what I first did actually was imagine that Z would be equidistant from both X and Y, because when I read the question, it said that Z detects the earthquake 1 minute later, for some reason I just presumed that that the earthquake was travelling from then X and Y to Z, whereas actually this isn't what the question's asking at all. In fact, are there any other places you could imagine that we could put Z instead? What about if we were to put it over here? Now at this point, the earthquake is going to be detected by X and Y at the same time, satisfying our first condition that we were given in the information in the question. But then the earthquake could also be detected by Z 1 minute later. So it would travel to Y, and then 1 minute later it would have travelled to Z and been detected. This is all that's needed to satisfy the two conditions given in the question. So therefore Z does not have to be equidistant from X and Y, and statement 2 is also false. So finally, let's look again at statement 3. Now this statement says that Z is no more than 240 kilometers from X and Y. So one way we could approach this is to try and consider the maximum distance of Z from both X and Y, and then compare it to 240 kilometers and see if it's more, less than, or about 240 kilometers. You also might guess that this is where our information on how fast the wave is travelling will come in, since it's the only number we've got in the question, and this is the only number that we've got in a statement, as well as the 1 minute, of course, in the information given. So to try and think about this question, I'm actually going to move where we put our Z location. So if we put it over here, then this just means that we can consider the earthquake travelling from directly to Y and then along the same line straight to Z. Now, you don't have to do this. I think it's just a bit clearer to see what's going on in this case. Due to the circular nature of the wavefront of the earthquake, we'd have to try and think about the earthquake moving to Z and the time between the two detections. So you could, of course, do it that way. It's just this way might be a bit clearer to see what's going on. So now, let's try and have a think about how far our point Z is from Y. So to think about this, we can use the information we were given. So we're told that the wave travels at 4 kilometers per second, and then it takes 1 minute for the wave to travel from Y to Z. So we can work out the distance between Y and Z in this nice, easy case. So in 1 minute, the earthquake is going to travel 240 kilometers. Now, this should look familiar since it's the number we're given in our statement. So handily, if Z is just 240 kilometers from Y, then it's quite easy to see that X is going to be far more than 240 kilometers from Z, and therefore this third statement has to be false. Now, another way of thinking about this question, just by the way, is that you might just instead wonder where the 240 kilometers comes from that were given in the statement. So, since the only numbers we're given in the question are 4 kilometers per second and our 1 minute, our 60 seconds, then it's not too much of a stretch to see that the distance that the wave travels in 1 minute is 240 kilometers. Now, hopefully, this might guide you towards this sort of idea, especially if you've worked out that Z could be in a position such as this one. So, since we know that the third statement is false, we can go ahead and say that the answer in the question is A. That is, that all three statements are false.